Hello, I am Shubhakar Nayak ji, lecturer in Polymer Technology, Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present PPT on Introduction to Polymers. Today's is a fourth session of Unit 1. Program is Polymer Technology, course Polymer Science of third semester. Course outcome is, at the end of this session, student will be able to understand basic concepts of step polymerization, polycondensation polymerization, polyaddition polymerization, and ring opening polymerization. Now before we begin the today's session, let us have a quick recap of previous session. We had come across ionic polymerization and coordination polymerization in our previous session. These are two different types of polymerization reactions which are useful to produce number of polymers. Now, in today's session, we are going to discuss about various topics like step polymerization, polycondensation polymerization, polyaddition polymerization, and ring opening polymerization. These are four different types of polymerization reactions which are useful to produce a number of polymers. At the end of this session, we'll have multiple choice questions related to today's session. Now, let us begin with the first one, that is step polymerization. In this type of polymerization, reaction takes place between functional groups of monomers. The reaction proceeds in stepwise manner. Therefore, the reaction product formation will be slow. In step polymerization reaction, elimination of byproduct will be there. That will be small molecules of some compounds will be going to form. Here you can see reaction between two different molecules having hydroxyl group and carboxyl group. When such two different molecules are put together and made to react each other, they will be going to react, and elimination of water will be there. One of the hydroxyl group with the another hydrogen atom, that will be going to form one molecule of water, and a linkage between the two molecules will be taking place, that is OCO linkage. Here in this example you can see acetic acid, and this is the ethylene glycol. Ethylene glycol has two hydroxyl groups at the ends. Hydroxyl group is a functional group, and this acetic acid has the COOH functional group. These two, when we put together and made them to react, then they are going to form like this. With combining of these two, formation of one molecule of water will be there. Next, see, let us take one more example. that is polycondensation reaction. How it proceeds is you can see over here. See this acetic acid with the previous reaction product of the previous step, ethylene glycol with the acetic acid, which is going to form this type of structure. And when you add more acetic acid into this, again one more molecule of water is going to evolve, and linking of this takes place over here, that you can see here in the reaction product. The product still contains another hydroxyl group at the end, which can react with another molecule of acetic acid to form ethylene glycol. That's what just we have come across. If you add more number of ethylene glycol to the reaction product, again there will be reaction and it's going to form a lengthy structure. The product still contains two functional groups at the ends. Say, as you could see, one more molecule of ethylene glycol, one more molecule of adipic acid. These two, if you add to the reaction product, again the reaction will continue, because between the hydroxyl group and carboxylic group there will be reaction, and elimination of one molecule of water will be there, and linkage between these two will take place. Similarly, on the other end, this carboxyl group and hydroxyl group will react each other, and again one more linkage will be there, thereby this is going to link up with this. So the reaction product will be of lengthy structure, and 2 moles of water is going to evolve here in this stage. The resultant molecule will contain again one carboxyl group and one hydroxyl group. If you add more ethylene glycol and adipic acid, then again the reaction will continue further, and bigger molecule will be going to form. If you add 4 molecules of the reactants to react, and a single product is going to form with the 3 molecules of water, and the product which is going to form is also having the 2 more functional group at its ends. It has the tendency to react further in presence of ethylene glycol and adipic acid. Now you can see here the growing chain with the 2 molecules of ethylene glycol and 2 molecules of adipic acid. The formation of the product you can see over here with the elimination of 3 molecules of water. So at the ends, hydroxyl groups and carboxyl groups are going to link up, and here also carboxyl group and hydroxyl group is going to link up. That is why the lengthy product like this is going to form. So we can sum up like this: 2 moles of ethylene glycol with 2 moles of adipic acid will yield 3 moles of water and the reaction product of higher molecular weight. In general, if we can write n numbers of ethylene glycol molecules are made to react with n numbers of adipic acid molecules, we are going to get the reaction product with the higher molecular weight. As you could see here, more number of groupings have added up, and 2n minus 1 numbers of water is going to evolve. So from the above discussion, what we can summarize is polymers which have two reactive functional groups only can polymerize, and this kind of reaction will proceed, that is polycondensation, polymerization. It proceeds in stepwise manner with the reaction between two different functional groups. Polymer formed will have functional groups at both ends. Hence, this product will be always in the active form and it is not dead, as we could see in chain polymerization. This reaction again of how it forms higher molecular weight compounds, we can see over here both reactive functional groups which have here NH2 group and carboxyl groups. In this case also the reactants will be going to react and water is going to evolve and a lengthy polymeric chain is going to form. So this way, if two different types of functional groups are present in the reactants, that type of whatever the product formation is there, that we call polycondensation type of reaction. Now let us discuss about another type of polymerization reaction, that is polyaddition polymerization. It takes place by the migration of atoms from one molecule of monomer to another molecule of monomer, or the migration of atoms will take place between intermediate products. Vinyl monomers or monomers pairs with reactive functional groups can undergo the polyaddition polymerization. In this type of reaction, there will not be any byproduct, as you could see in the polycondensation reaction. Let us take one example. Styrene monomer. If you made to polymerize styrene monomer in presence of perchloric acid, this will proceed in the formation of the product like this. This is the styrene molecule, styrene monomer, one molecule of that. This is another molecule of styrene, or it is also called as vinyl benzene. These two will react like this. The migration of atom from this double bonds will take place. This one atom of hydrogen is going to migrate from here and it is going to form CH3, and a link between these two molecules will be going to take place here. And if this is the now in the first stage of the reaction, if one more molecule of styrene is made available to react with this, this will be going to link up like this. The hydrogen atom from here, it will migrate and it will be going to link up with this, thereby this becomes CH2 and this double bond will break and a linking up of this molecule takes place here. If n numbers of styrene molecules are made available, then the reaction will continue in the same manner and you can see the reaction product like this. Inside the square bracket we have shown here, that is CH2CH C6H5. This is the repeating unit, and at the head end there will be CH3CH1 molecule will be there of styrene with the one more hydrogen atom, and at the end there will be CH C6H5, that is at the tail end of the reactant. That is the speciality of polyaddition polymerization. Now let us discuss about another type of polymerization reaction, that is ring opening polymerization. This type of polymerization is useful only in monomers which have ring type structure. In polymerization, the ring structure will be opened and it will be polymerized. Opening up is the opposite of condensing process. The condensing of bifunctional low molecular weight compounds can give cyclic or ring compounds having stain-free configuration. See, this is the example. Let us take for discussion. Ethylene oxide is shown over here, CH2CH2O. This is ethylene oxide. This is sodium methoxide. Ethylene oxide and sodium methoxide, when put together and made to react each other, it will be going to react and going to form product with this. The positive charge having sodium, this will be at the one end, and negatively charged OCH3 will be linked up by opening this ring type structure, thereby OCH2CH2 with OCH3 at the end it will be there. So this is a positive charged and whole this will be a negative charged one, that you could see here in the product. In the second step, that is the what we have seen is the first initial step. In the second step, the propagation will take place. More and more fresh ethylene oxide molecule, if you put together, then the chain growth will be there. The opening of this ring will take place and it will be going to link up here, and this OCH3 groupings will be at the end. Similarly, this reaction growing chain, whatever you could see here, if you supply n numbers of ethylene oxide to this, then the reaction product we can write like this. This OCH2CH2 will be n times, and the remaining this will be with this, along with this will be there at the head end and at the tail end of the reaction product. Now in the third step is about the termination step. In this, growth of polymer chain is arrested. At the end, a stable structure is going to form, and the formation of hydrochloric acid and sodium chloride will be there, that you could see over here. Now at this stage, hydrochloric acid is going to evolve, and at the end, the sodium whatever is there with the chlorine atom, it is going to form the sodium chloride. Now let us have the multiple choice questions. Let us discuss about. The first question is coordination polymerization is carried out using dash. Answers are organic compounds, metallic compounds, organometallic compounds, inorganic compounds. We conduct coordination polymerization with the help of organometallic compounds. Then only the reaction proceeds and will be able to produce the polymer. Second question. The first step in polymerization process is in the formation of dash complex between monomer and organometallic compound. The first step is the formation of monomer catalyst compound. Question number 3. In coordination polymerization, the catalyst monomer complex is dash system, heterogeneous system. Correct answer is heterogeneous system. Question number 4. Coordination polymerization is also known as dash polymerization. It is not the bulk, it is not the mass, no emulsion, only insertion takes place. Fresh diene compound what we have added up, that will be going to inserted. So that is why it is called insertion polymerization. Question number 5. Coordination polymerization is used for dash monomers, olefin, dienes, vinyl, and both A and B. For olefin as well as for diene compounds, we conduct this coordination polymerization reaction. Question number 6. Polycondensation is brought about by monomers containing functional groups, hydroxyl group, carboxyl group, amino group, all of these. Correct answer is all of these. Question number 7. Polycondensation proceeds in dash manner. Stepwise, gradual manner, rapid, all of these. Polycondensation proceeds in stepwise manner. Reaction between hydroxyl and carboxyl group gives dash. Water, ether, ester, all of these. It gives ester. Reaction between hydroxyl and carboxyl group is ester formation. 9. Reaction between methanol and acetic acid gives us dash. Methyl acetate it is going to form. Next question number 10. CH2, CH2, OH, OH on both sides. This is called dash. This is ethylene glycol. Question number 11. In ring opening polymerization, monomers having dash can be opened and polymerized. Ring opening, ring structure, that is the correct answer. Next question is, ring opening polymerization proceeds in 3 steps, that is initiation, propagation, termination. This statement is true. So correct answer is A. Ring opening polymerization is similar to dash chain polymerization. It is similar to ring opening, it is similar to anionic chain polymerization. Question number 14. Ethylene oxide has dash type of structure. Ethylene oxide has a ring type of structure. That's what we had discussed just now in ring opening polymerization. Thank you.